And I think for a lot of folks, performance enthusiasts, there's a temptation to jump right into PMUs. While really interesting, jumping into PMUs is like having a headache, so needing to get brain surgery.
Hey everyone, welcome to the next video in our Dev Impact series. In the past few videos, we've gone over our Ampere performance toolkit, the methodology, our ethos behind developing it, and other things. In this video, we'll specifically deep dive in one of the most important tools in our framework, which is called the Ampere System Profiler, also known as ASP. And with us, we have Tito Reinhardt, who is the lead developer for ASP at Ampere. And hi, Tito. Can you introduce yourself?
Yeah, of course. My name is Tito Reinhardt. I work on the software application engineering team, developing different performance tools and other applications for our performance benchmarking. And additionally, the open source tool, the Ampere System Profiler, or ASP, to help other engineers and performance enthusiasts try to diagnose system bottlenecks while they are benchmarking their application, which I think is an enormous skill to develop for any engineer who's looking to maximize performance on their fleet of machines.
So can you talk a little bit about why did we feel the need to develop a tool like ASP? What were we really looking for as we wrote a tool like a system profiler?
I think for a lot of folks, performance enthusiasts, there's a temptation to jump right into PMUs. And I think that is, while really interesting, it is sort of, as I was shared earlier in my career, jumping into PMUs is like having a headache, so needing to get brain surgery, right? There's an intermediate part here. And the neat thing about ASP specifically is the fact that it takes a bunch of Linux utilities that are really useful for looking at different system peripherals, and it combines them into one, both concurrently doing a profile with, systat, mpstat, LM sensors if you're looking at socket power. So to get back to your key question, why was this tool developed? Why does it exist? It basically exists for other engineers to have a simple CLI interface to run a profile in the background during any application and have a very easy to read report without having to run multiple different profiling tools concurrently on their own.
So essentially, what you're saying is our ethos was we wanted to instill a framework where we wanted to make sure that we look at system utilization before diving deep into the problem further. One, and then second, we didn't want our users, developers to get overwhelmed with a large variety of different tools available. And we wanted to give something that's simple to use, but still gives well-informed first pass report.
Yeah, exactly. I think that's a really great way of putting it.
And do you recall that one time when we were debugging a Redis performance issue that led us to find why are we seeing a 60% regression comparing two production VMs, gen over gen, which was completely out of what we would expect when we measure performance for such VMs.
That was a fun one. Yeah. Redis in particular is a common benchmark that we make, but it's also a somewhat challenging benchmark. Redis mem tier, so our load generator mem tier, stresses a Redis server, fills up the data cache, and then the requests come in to retrieve that data from memory. But often we are running, a client server topology. So we have a client system running over a network, interfacing with a network interface card, and then that request is then sent to the CPU to retrieve data from cache, and then comes back and acknowledged by the mem tier server across the network.
Redis and Memtier were in this case running over the network in two production systems, and we were observing a 60% performance difference in measured throughput on these two systems. That's something we couldn't explain. Now, when Redis is run over the network IRQs are a key part of this test. So it really depends on how these IRQs are scheduled, what cores are they pinned to. That essentially limits what cores are available for the application itself to run the test. So in this case, when we used ASP, it was very clear looking at the report that our system A was having a different IRQ configuration compared to a system B. So although as performance engineers, we felt we're running the same test on the two systems and kept figuring out why are we seeing a 60% delta. The key was that the VMs were configured differently in terms of their IRQ utilization. And what that meant is if one VM had more cores assigned to IRQs, it had less cores for the application to use for Redis requests, for example.
Yeah, exactly. And in fact, that would show up in the report itself, right? I mean, because we are getting the network bandwidth during an ASP profile, we can see exactly how much network bandwidth is being utilized during the sample period. And additionally, we also are getting a perf report. So additionally, we see at the perf hotspots. And if we can see a percentage of cycles are getting handled differently between system A and system B based on the IRQ interrupts, then we have a pretty good idea that, hey, even though we think the application is running, it's similarly configured on both system A and system B, that they're not running the same. The behavior is not the same. And that's pretty clear when these reports get generated.
Yeah, and then when we further deep dived into this problem, we obviously configured both the VMs in the same way now that we identified that their IRQ core distribution was not uniform. And then that 60% gap moved to just 15%, which was more in the realms of what we would expect to debug. And then, if I recall correctly, that 15% debug was then looked at with perf records, and we found that the virtualization code needed optimizations that got us back that 15%, right?
Yeah, it definitely helped. And I think ruling out the system differences, and then you can kind of go further and then do more profiling to say, well, what else is holding us back?
So what helped close that 15% perf gap that was down from 60%?
Yeah, that's interesting. It was the lockstat data structure that needed to be optimized in order to further close that gap.
So let's jump right into the demo and show them how to set up ASP on their systems.
Yeah, of course. So as I mentioned earlier, ASP is a open source project. Anybody can clone it and get started immediately. But I'm going to quickly just kind of run through the README and just sort of outline the install steps. We've tried to make this as simple as possible for people to get up and started easily. There are some system prerequisites for just specific profiling commands, include SAR, sensors, NUMA stat, perf, etc. These are pretty common, and we have some general install steps, whether you're running on a RHEL-based system and an Ubuntu or Debian system, and then additionally some of the Python modules that are needed in order to install. We've abstracted a lot of this stuff with a setup script, so all you really need to run is just source setup.shell, and you should be good to go. We do note the specific OSs that we have tested on to date. So, and this is as new OS versions come out, we update this list on a rolling basis. This is what a sample report looks like. Basically, we capture the CPU utilization, per core utilization, CPO and IO power, frequencies, the function hotspots, network utilization. To get started, we just run source setup.shell. So if you want to have a portable wheel file so that you can run on a different system or just ship somewhere else for a simple utility, you can do a poetry build, which will create a dist directory and a specific wheel file for you to install as well for convenience. Example command lines for ASP help, which will just output the commands that you'll need to run, and just some simple sample commands. By default, when you run ASP, there are two key parts that you need. You need the number of samples and you need the interval that each sample gets collected.
That's dash N and dash I.
Correct. So so dash N and dash I for number of samples, I for interval. Capital N is passing the network interface. So if you were looking specifically for your network bandwidth, you want to make sure that the IP that you're running on is tied to the network interface alias that is output from that, and then you just simply input that to collect the network bandwidth. If you want to just collect a certain set of collectors, you can basically indicate which collectors you want to run. So in this case, for example, you can do CPU frequency, CPU power. If I'm just running, I want to see how the CPU is performing, but only the CPU. And again, the ASP help function will output all possible command permutations that you could use. So let's set it up. One other caveat is that you need sudo permissions in order to run this. So if you're not running as root directly, you can create a simple bash script, run sudo your bash script with the commands that you want, and it will run no problem. So we want to just set up the system. So I'm going to do a source setup.shell. And then we're saying, hey, we detected Ubuntu. We're getting all the upgrades that we need. We're doing our pip installs. And now we're doing the poetry build for all the PyProject.toml dependencies. And you can see in the left-hand side, now I have this venv. So my virtual environment has been created for me. This is all the virtual environment dependencies that I need to run the ASP CLI. And I can verify that ASP is working by running ASP help. And there it is. I have a very simple setup ready to go. We can run a profile right now if you're interested.
Yeah, sure. Let's do that.
Good. So I'm not running as root. So I am going to basically call a very simple bash script. And basically all it is it's just simply just sourcing my venv. It'll output the help command just to validate, hey, this is working. And then I am just doing a very simple ASP for 60 seconds at a 1 second interval. This capital F is a perf function to limit the frequency, the perf collection, and then the network interface card outputting to my file test demo. Let me get a benchmark running, and we'll verify that the benchmark is running via htop. You can see that we're running Redis. The Redis server processes are running here. And we can see, yep, we have a pretty good utilization going here. So sudo bash run.shell. Yep, got our help. We're running ASP. And there it is. So we're collecting 60 samples at a 1 second interval, and it'll output the specific collectors that we're running.
And what collectors are we collecting right now?
We're collecting CPU data, we're collecting frequency data, power data, and this is LM sensors, so it's socket power. We're collecting any disk I/O data, any network IRQ affinity data, and any memory subsystem commands, the NUMA system.
If it's a new workload, the recommendation is start ASP, then start the test, stop the test, and stop ASP. Essentially, you have ASP being collected outside of your runtime. That makes sure you see all of your ramp up, ramp down. And then in this case, since we know Redis as a workload pretty well, we wanted to just collect it after it hit steady state. So then Tito started Redis, ensured that it ran steady state, and then we're now collecting ASP.
And that's pretty much it. Test terminated. Processes are going to clean up. I wrote out to a new test demo file, which basically is, here are the new logs that have been created.
So other than the report, you also get a dump of all the raw data that's collected. If you want to plot your own graphs or look at other metrics, that's a possibility.
Yeah, exactly. And so we intentionally wanted to make sure that a user could use the data in any way that they needed to for more thorough study if they wished. And we will just take a look at some sample reports of what's generated for the run that we had just done. I was debugging a Redis local host, so running the client server on the same system, and wanting to understand if the configuration I was running is really optimized for the platform that I am on. This is one of the Redis reports that was just generated using ASP. And what we are looking at specifically with this report is a couple of high-level output. We have the CPU utilization over time, 60 samples at a 1-second interval. So this is tracked over a 60-second period. The per core utilization. So we're looking at all the cores on the system and the average CPU utilization over that 60 seconds. We have the socket power. This is basically looking at the total socket power, that's this top line here, during that particular run. All the average CPU frequencies for each core during that run. Any memory, NUMA stats, disk I/O, and then network utilization. And then lastly, and I think this is one of my favorite ones, is the CPU hotspots. What is the application as percentage of cycles doing during the sampling period? So you can see that the majority of the cycles are done on the Redis server, and then a particular function within the Redis server that is taking place during the sampling period.
And then we deep dive into hotspots independently later too. But I guess the goal of having it here is to just make sure we're looking at the right report. We're not profiling idle time for majority of our runtime, or we're not profiling like a heavy lock driven use case. What we're seeing is like real application work, basically.
Yeah, exactly. And you can see that, within this particular configuration is that I have it configured to run on local hosts. So network bottleneck shouldn't be a problem. And you can see that confirmed here that effectively the network utilization is near zero. We're not using a lot of network here. I have the memtier client pinned to the first half of the socket, so cores 0 to 47, and the Redis in each Redis server pinned to the second half of the socket, cores 48 to 95. And so here I'm trying to optimize the Redis configuration to maximize throughput. So with that in mind, the memtier client fully utilized through the whole run. But the Redis server, the utilization seems to be really low. And that to me tells me that the configuration that is chosen for this particular benchmark in this setup isn't maximizing its potential. And so there are probably some tunables and some edits and tweaks I need to make to the memtier server in terms of client configurations, pipeline configurations to improve Redis performance. And so if I do some scaling studies and I take some samples and compare them, I can see with a different improved configuration getting better, we're seeing lower client utilization and higher Redis server utilization. And so I'm saying, hey, I'm moving in the right direction. The changes I'm making to the configuration are getting me better throughput. With the utilization pretty low on the Redis server side, there's room for improvement in terms of tuning the application. Finding a best configuration and then running that configuration and profiling that configuration comparatively, you can see that the Redis server utilization on this system increases substantially, looking at cores 48 to 95. In fact, it's a 20% increase in average utilization during the course of the benchmark. So it's pretty significant, and inevitably led to a pretty significant gain in performance as well.
Cool. That's awesome, Tito. Thanks for walking us through the demo and some example reports. Highly encourage all our listeners to use ASP, clone the repo, contribute to it. It's an open source project. Happy testing.
Yeah, happy testing.